Okay, yes, we have to study addition of vectors. I think you are able to see the screen. So, can you see the screen, children?
Yes, ma'am.
Oh,
Yes, ma'am.
okay. Then addition of vector. Vector we cannot add by the method of addition used in algebra. That method we cannot use to add vectors. So what is a vector? A vector quantity is having both magnitude and direction. Example for vector quantity: displacement, velocity, acceleration, force. All are examples for vector quantities. Vector quantities have both magnitude and direction. Okay. And here you can see two vectors here. A vector A. This is vector A. And a length, length of the vector gives magnitude. For example, 5 meter. Suppose this is a displacement vector. This length gives 5 meter. That is the magnitude. And arrowhead shows the direction of the vector. It is in this particular direction it is acting. So vector, when you study vector, direction and magnitude both are important. Okay. So two vectors are given. Vector A is represented here, and you have to measure the length of that vector, and the direction also like this. And vector B also, it is another color is also given to understand this is vector B. Its direction is like this, downwards like this, slanting line, vector B. So we have two vectors, vector A and vector B. How can we add these two methods? Now we are studying graphical method of vector addition. Very easy method. Graphical method of addition of vectors. That is very easy, but only to keep certain things in mind while adding those two vectors by graphical method. First, I will tell you, all of you have to listen very well. Very easy thing, but you have to understand it clearly. Then only you can add it properly. So now, what is given to you? Two vectors, vector A and vector B is given to you, and you are asked to find A plus B. Vector A plus vector B. That is what you have to find out. So what you have to do is another place, you see near to it, another place, you have to represent vector A. So first you measure this length. Suppose it is 5 centimeter. Okay. Then you have to take 5 centimeter, and also one more thing you have to be very careful, its direction. So when you draw a line at another place, you can draw it here, left side, up, down, right, anywhere you can draw this vector. But what is important? Its direction is important. That means it when we draw another line near to it, that must be parallel to this. Parallel. Yeah. So even though I have drawn it here, it is making a 0 degree. That means parallel line. You can draw it here like this. You can draw a line parallel to it, but don't draw like this. 5 centimeter line and draw downwards, upwards. Don't like that. You have to draw a vector A with the same magnitude and same direction. That is very important. Okay. So now I have drawn 5 centimeter length vector and it is parallel to vector A. So vector OP, I named it OP, vector OP. Vector A is represented by the vector OP. O is the tail of the vector and P is the tip of the vector. Tip or head, it is also known as head. Tail, tip. Tip is also known as head. Okay. So now I have only represented vector A with same magnitude, same direction. Next part, A plus B is asked. So B vector we have to keep at the tip of vector A. This is the tip of vector A. But tail of vector B is kept at the tip of vector A. So when we, this is 4 centimeters, suppose this is 4 centimeters, like, and its direction also we know. So at the tip of vector P, you have to draw 4 centimeter length vector, 4 centimeter length vector. What direction? You cannot draw upwards, you cannot draw towards right, you cannot draw towards left, but you have to draw a line parallel to this vector B, and this must be parallel to it. That is very important. So at the tip of vector P or vector A, tip of vector A, tail of vector B is kept, and then you draw a 4 centimeter length vector parallel to B. That is very important. Parallel to B, you have to draw a line. Then we got tail of vector A and tip of vector B. Join with a line with the green colored pen. I have drawn it. Green colored pen I have drawn it. Joining, what is joined there? Tail of vector A to the tip of vector B. Now that will represent the resultant vector. Resultant vector is the sum of these two vectors. A plus B. Resultant vector will give the same effect as is produced by the individual vectors. Okay, so this is A plus B. Now we got A plus B. Very easy now. What is to be careful? Magnitude, you have to take carefully. Direction also you have to be very careful. And first vector A is drawn in order to find A plus B. What is drawn first? First vector A is drawn. Then at the tip of vector A, tail of vector B is kept. How is it kept? Parallel to B. Parallel to B. Same magnitude. Measure the magnitude and also see the direction, whether this vector and this vector B are parallel to each other. That is only you have to be very careful. Then problem is over. Next only to join tail of vector A to the tip of vector B. So that will represent vector R. R is the resultant vector. Resultant vector R is equal to vector A plus vector B. Now another important thing, when you draw vector A, put arrow mark at this end. And when you draw vector B, put arrow mark at this end. That is the tip of that vector. Then when you draw join tail to tip of this vector B, there also you have to put an arrow mark. That is very important. So resultant vector we got now. Similar, so A plus B is done now. Vector R means resultant. Resultant means sum of those two vectors. So next step is B plus A. How will you draw B plus A? Let us see. So B, first you have to represent B. For finding A plus B, first what you have to draw? You have to draw vector A. For finding B plus A, what you have to draw first? First you have to draw B. So I have drawn B vector here. 4 centimeter length. This is having 4 centimeter and this also is having 4 centimeter. Direction, be very careful. This must be parallel. This vector B, when we represent near to it, that must be parallel to the given vector B. Given vector B. So I have represented vector B here, tail at Q and tip at S. It is represented. Then we mute your mic,
Teacher,
please. Huh?
the one shall admit you.
Okay. Okay, 38. Okay, now almost all present today. Even though late, they all are present. 38. One more is there. No, 39 is there. Okay. Jnana Prakash also there. Okay. So B plus A. We are going to find B plus A. Children, be careful. First, you have to represent vector B with same magnitude, same direction. Okay, that is that. Next step, B plus A, where we have to keep A at the tip of B. At the tip of B, keep tail of vector A. Tail is kept here. And how will you draw it? Which direction? It must be parallel to this. So when you draw a line here, that must be parallel to this vector A. Parallel. See, these two are parallel. This vector A, this vector A, they are parallel. Like that you have to draw. Magnitude, you have to be very careful. If this is 5 centimeter, this also must be 5 centimeter length. And here put arrow mark here. So tail, tip, tail, tip. Like that you have to keep. Tail to tip method. This is also known as tail to tip method. Tail, tip of the vector B, and at the tip of the vector B, tail of vector is kept, and we got tail, tip, like that. Then how will you find B plus A? Join tail of vector B to the tip of vector A. So with the green color pen I have drawn it. Tail of vector B to the tip of vector A line is drawn that will represent, and an arrow mark is put, that will represent B plus A vector, resultant vector, resultant. These two are vectors. What is the resultant of B plus A? For finding that, we used tail to tip method or head and tail method, or a tail tip method. Okay, that is done here. And one more thing, you see, I have drawn it very near to this. These two figures are near, and you see both are having resultant. A plus B is having, when you measure its length, this R will be same as this R, because A plus B equal to B plus A. Figure 1 and figure 2, the resultant vector is, they are parallel. You see, they are parallel. Magnitude also same. So if you take correct measurement, you will get the same magnitude for this. Both these are, both the resultant, you will get the same magnitude and same direction. The same direction, how can you tell? They are parallel. So you can tell they are having the same direction. If they are parallel, you can tell they are having the same direction. So this is the method to find A plus B by graphical method. So A plus B equal to B plus A. Vector addition obey commutative law. So that is the property of vector. So if property of vector is asked, you can write this property. We have studied some properties earlier. When a vector is multiplied by a real number, that real number times that vector we get. And unit vector is a vector having unit magnitude, and direction will be same as that of the given vector. Such properties also we have learned earlier. Now this is, in addition to that, you can study this property also. A plus B equal to B plus A. Vector addition is obey commutative law. Okay, next page. Okay, this one. Vector addition obey associative law. That also we have to see with the diagram. Vector addition obey associative law. A plus B plus C equal to A plus B plus C. We have to show that. A plus B plus C. A, B, C are three vectors. A plus B plus C equal to A plus B plus C. Both are same. We have to prove that in order to show the associative property. Vector addition obey associative law. So here different vectors are not drawn directly. One figure is given. Vector A is drawn here. Vector B is drawn here. A plus B we know. A plus B is tail of vector A to tip of vector B. A plus B, this pink line that represents A plus B. Then A plus B plus C we have to find out. A plus B plus C. So this is vector C. At the tip of vector A plus B, tail of vector C is kept. And then tail to tip it is joined. Tail to tip it is joined. That will represent A plus B plus C. A plus B plus C. So this vector, the blue line, that blue line represents A plus B plus C. Next step we have to see A plus B plus C. What is a plus b plus c? If it is the same line we are getting, that is getting proved that. Okay. So first we find out b plus c. I forgot to draw that line b plus c. B to C you have to draw a line. That is B. This is vector B, tail, tip. Tail, tip. And tail to tip you have to do. Tail of vector B to the tip of vector C, draw a line. That will represent B plus C. Now I forgot to draw that line. Actually B plus C is this. B plus C. Then you add with A. This is A, vector A. And here arrow mark also is to be put, arrow mark. So tip of vector A to B plus C is this vector. So we get the same one, tail to tip of B plus C. Tail of vector A to tip of B plus C. So we are showing both are the same vector, resultant of A plus B plus C. That is same as A plus B plus C. Both are same. So all this you have to draw diagrams. You can draw anywhere, any way, 2 vectors or 3 vectors you draw and do like this and show the associative property. Next is null vector. Null vector. Textbook also you can refer. Textbook it is given. So not only note, text also you have to read. Okay. Next is null vector or zero vector. Unit vector we have seen. Unit vector means a vector having unit magnitude. Magnitude is 1. Direction same as that of the given vector. Null vector, as the name shows, null vector or zero vector, as the name shows, magnitude is 0 with no specific direction. No specific direction. Zero vector, magnitude is 0 and no particular direction. Such a vector is known as zero vector. So when you add a vector A plus minus of that vector A, vector A is added with the minus of that vector A. What will be the resultant vector? That will be zero vector. Similar, so vector A minus A plus minus becomes minus. Vector A minus vector A equal to 0 and modulus of a zero vector is 0. Modulus. We have 2 lines are drawn. Which represent is the modulus of vector, zero vector. Modulus of zero vector is 0. Magnitude of null vector is 0 and its direction cannot be specified. So what is zero vector? It is having magnitude 0. What is the direction? It is not having any particular direction. Direction we cannot specify. Direction cannot be specified. So properties, that is the property of zero vector, and some more properties are there. Just like 0. When we add 0 to a number, we get that number itself. Like that. Vector A plus 0 vector gives that vector itself. No change to its magnitude or direction. 0 vector is added. Then lambda times, lambda is a real number. 5 times 0 vector. What it will be? 5 times 0 vector. What it will be? 0 vector is just like that. 0 is having that property. 5 into 0, 0. 6 into 0, 0. Like that. Lambda into 0 vector. That will be 0 vector itself. Then 0 is multiplied with a vector. 0 is multiplied with a vector, then also 0. So multiplication we can see 0 vector. Real number into 0 vector, 0. 0 into vector A, that also is 0. Okay. When example, when a body is at rest, you consider a body is at rest. What is its velocity? When a body is at rest, what is its velocity? Velocity is 0. When a body is rest means velocity is 0. So velocity vector is 0. That is an example for 0 vector. Velocity vector of a body at rest is 0. So another example. Here you can see a figure. XY, you can see x-axis. Here x-axis is taken and here y-axis is taken. Here position is taken. Position. Here time is taken. Position time graph. And consider body at P. Initially it is at P. Initially body is at P. And it moved to P dash. Then after reaching P dash, again it returned to P. So what happened here? Body first moved from P to P dash and then back to P. back to P. What is the displacement vector? Is there any displacement when it reaches to the same point? No. Distance is there. Distance we have to add. Suppose this is 2 kilometer and this again you have to go back to the same place. So 2 plus 2, 4 kilometer is that distance. But displacement is the shortest distance, straight line distance between initial and final position. Initial position is P, and when it returns the point P, final position is also P. So there is no displacement. Displacement vector is 0. So 2 examples are given. Okay. Next. Okay, next. Position vector and displacement vector in a plane, that we have to discuss. This is the beginning, and other things are only when you enter into a new chapter, some things you should know. No, that's why. And this from here we have to start. Okay, position vector and displacement vector in a plane. So a plane means what? Two-dimensional motion. When a body move in a plane, it is a two-dimensional motion. So here, this is xy plane is shown here. Origin, this is x-axis, and this is y-axis. And when a body move here, it is moving in xy plane. When a body move in this plane, this motion is two-dimensional motion. I told you, when you write in a book, when you write in a board, all these are two-dimensional motion. Both x-coordinate and y-coordinate will change with time. Suppose body is here. What is its x-coordinate? You draw a line here. Suppose here it is 1. X-coordinate is 1. And here you draw a line perpendicular to the y-axis. Suppose this is 9, 0, 9. That is its position. Position vector 0, 9. Okay, like that. So then when it move from P to P dash, body is moving. Body is moving. So when it reaches to P dash, x coordinate is changing. Earlier it was 1, now it is 3. For example, I am telling example. Now it is 3, x coordinate is 3, and y coordinate is reduced. For example, suppose it is 8. X and y coordinate both are changing with time. X and y coordinate both are changing with time. So such a motion is motion in a plane. Here the body is moving in x, y plane. So first you can consider body is at P. This dark colored line, that represents the motion of the body. Motion, body is moving in this direction, like this. And we have at a particular time t, the body is at P. At a particular time t, body is at P. And how will you represent position vector? We are studying that position vector. At a time t, body is at P. How will you represent position vector? From origin, you draw a straight line to the point P. From origin, you draw a straight line to the point P. Then put an arrow mark that will represent position vector, vector OP. Usually, position vector is denoted with the letter R, small letter R. So, at a time t, body is at P and its position vector is represented by vector R. Okay? Then body is in motion in this plane, and at a time t dash, body reached at P dash. At a time t dash, body reached at P dash. Now how will you represent the position vector? From O, from the origin, you draw a straight line to the point P dash. P dash. Then put an arrow mark also which shows the direction from origin. It is this much distance away and it is in this particular position. Body is in this particular position from the origin. And how far it is from the origin. In which direction body is moving. And that things position vector tells us. Position vector tells us two things. How far it is from the origin and in which direction the body is moving. These two things the position vector tells us. So at a time t, body is at P. Its position vector is vector R. How is it drawn? Draw a straight line from origin to that point P and put an arrow mark on it. At a time t dash, body is at P dash. How will you draw the position vector? Draw a straight line from O to that point P dash, put an arrow mark on it. So that will give the magnitude of the position, how far it is from the origin, and in which direction it is moving. These two things the position vector tells us. Here it is at a time t dash, body is at P dash, and its position vector is R dash, vector R dash. Okay, all these things are explained here. So after class you can take down the notes and you can again read. And class also Ridu Varna is I think. Okay. So all this what I explained here, that is written here. You have to just go through that. Okay, next one. Next displacement vector. Position vector I told you. Next displacement vector. So again I have drawn the figure. Otherwise you have to turn to go to that same page again and again. So I have drawn the figure again here. X-axis, Y-axis, body is moving from Q to E, for example. Okay. So here, when a body moves from Q to E, it can take different paths. QAE, you can take QFE, you can take path length. You can take this along this path also. You can go and reach the point E. Different path you can select. So that is the path length. That gives the path length when body move from Q to E. Displacement vector is actually the straight line distance from Q to E. So when you draw a straight line from Q to E, that represents displacement vector. Other distances are only distance or path length. The QFE, you measure the length of the path. That is the path length. And QCBE, that also path length. Different path you can select. QAE, longer than this displacement. All the paths are longer than the displacement vector. Displacement vector will be the shortest one, shortest distance between initial position and final position. That is the displacement vector. Vector QE is the displacement vector, straight line distance from initial position to the final position. So where is the initial position? At Q. Where is the final position? At E. So you draw a straight line. That will give the displacement vector. So displacement vector gives us what all things? It is a vector which tells us how much and in which direction an object has changed its position in given interval of time. So in a given interval of time, when the body moves from T to T dash minus T, that is the interval of time. So in that interval of time, how much distance the body traveled, in which direction the body traveled, all these things the displacement vector tells us. So only important point is that displacement vector is that vector which tells us how much and in which direction an object has changed its position in given interval of time. So now we have studied both position vector and displacement vector. Next is subtraction of vectors. Addition we have seen. Graphical method of A plus B we have seen. Next is subtraction of vector. Subtraction is actually adding itself. Suppose we have to subtract B from A. Subtraction of vector can be defined in terms of addition of vectors. We define the difference of two vectors, vector A and vector B, as the sum of two vectors A and minus B. So when A and minus B are added, we get A minus B. So vector A plus minus of vector B. I'll show you the figure. You can see subtraction of vector here. You can see vector A. This is vector A, orange colored line, that is vector A. And a magnitude, you have to see the magnitude with the scale, you have to measure its length. And direction, the arrowhead gives the direction of the vector. And B is drawn like this. B, vector B, green color. That is vector B. And minus of vector B, we have to subtract. A minus B, we have to find out. So minus B also you have to draw. Minus B, how will you draw? It is an equal magnitude, but direction opposite. If this is 3 centimeter, this also must be 3 centimeter and direction opposite. So they are parallel, but this you can say anti-parallel, opposite direction. So anti-parallel, same magnitude, but opposite direction. So this is minus of vector B. What we have to do now? We have to find A minus B. So what will you do? A, at the tip of vector A, tail of vector minus B is to be kept. A minus B. A minus B is actually A plus minus B. A plus minus. Let us see in figure. This is vector A. So you draw it here. You can draw it here, or you can draw it here. Anywhere you can draw. But I have drawn it here. OP. Vector A is OP. How you have drawn it? Same magnitude. Measure this length. Suppose it is 4 centimeter. You have to draw 4 centimeter line. Can you draw it downwards? Can you draw it upwards? No. You can draw it parallel to this vector. Make it parallel and draw. And so now we have represented vector A with same magnitude and same direction. Vector OP. Name also given. Vector OP is vector A. Name is given to vector A. Now tail of vector A, tip of vector A is here. Then in order to find minus B, at the tip you have to keep minus B vector. Minus B vector. Tip of vector A, keep tail of vector minus B. It is kept. How is it kept? Same magnitude. Measure this length. Suppose it is 3 centimeter. You have to draw a 3 centimeter line. How you can draw? Parallel to this vector minus B. They must be parallel. This minus B and this minus B. They are parallel. Like that you have to draw minus B vector. Now I have drawn tail of this vector A and minus B also we have drawn. Then add A and minus B you have to add. How will you add? Tail to tip method. Tail of vector A join with tip of vector minus B. Blue color line. That is A minus B. A minus B. Tail of vector A plus tip of vector minus B. So join with a line, that is A minus B. And for a comparison, you can find A plus B also. Actually, question is A minus B. This is enough. But for comparison, I have drawn A plus B also here. See, B vector we know, this is green vector, that is vector B. So at the tip of vector A, you keep tail of vector B with same magnitude, same direction. Very careful. So I have drawn vector B here. And tail of vector A to tip of vector B, join. And put arrow mark. Tail to tip. Tail to tip. Don't put arrow mark here. Okay. Tail, initial point is tail. Tail to tip you have to draw the line. And at the tip you have to draw arrow mark. Don't put arrow mark here. Be careful. This is tail. Tail to tip. You have to draw a line. That gives A plus B. Now you can see A minus B is bigger one. Longer length. And A plus B is shorter one. Direction is also different. So A plus B and A minus B are two different vectors. That's why here it is given as vector R2 resultant. A and minus B are added. Here R1, vector R1 equal to vector A plus vector B. Both are different vectors. Their magnitude is different, direction is also different. Next is resultant vector definition. Now we found a plus b, that is a resultant vector. And what is the resultant vector definition? The resultant vector of two or more vector is defined as that vector which produces the same effect as is produced by the individual vectors. So what is resultant vector? It is a resultant vector of two or more vectors. Resultant vector of two or more vectors is defined as that single vector, that will be a single vector, which produces the same effect as is produced by the individual vectors. I will tell one example for that. Suppose two children are pushing a table. You can those children can push from anywhere. They are pushing the table, and the table moved in one particular direction. For example, 1 meter it moved. By two persons are applying a force on the table, and the table moved to, for example, 1 meter distance in a particular direction. So two individual forces are acting on it. Instead of that, if a single person apply force, and if it moves in the same direction with 1 meter distance only, that is the resultant of those two forces. Instead of those two forces, a single force comes here. So that is also producing the same effect as is the individual forces. So resultant force means it is the sum of those two forces. It produces the same effect as is produced by the individual forces. So that is an example for force, and that is applicable to all the vectors. So resultant vector means it is a single vector which produces the same effect as is produced by the individual vectors together. So that is the definition. Definition you have to study well. Vector addition is not possible by simple laws of algebra. Vectors are added by triangle law of vectors or parallelogram law of vectors. Now we have these methods are geometrical method of addition. There is some other method, that is triangle law of vectors and parallelogram law of vectors. So only 5 more minutes remains to get our meeting over. Okay. Before that, I will ask the attendance of some children. Aditya T.S., are you present?
Yes, teacher.
Okay. Then Muhammad Adil, are you present? Jodham. Pranav TP? Pranav TP. No answer. Sagar? No answer. Abarna?
Teacher.
Sagar present?
Yes, teacher.
Abarna also. Okay. Then Mitra present? Mitra? No. Ridhubarna present? Yes. Okay. Okay. Okay, we can continue. Vector addition is not possible by simple laws of algebra. Vectors are added by triangle law of vector addition, parallelogram law of vector addition, and one more law is a polygon law of vector addition. Like that, only we can add vectors. Triangle law of vector addition, I don't know whether we will get time, but we can try. Okay. Triangle law of vector addition. Yes. You can see two vectors. I will explain that. Two vectors. Statement we can do later. Two vectors, vector A, vector B are given. And you know tail to tip method. First vector A is drawn with same magnitude, same direction. At the tip of vector A, what is kept? Tail of vector B is kept. How is it kept? They are parallel. This vector B and this vector B, they must be parallel. Blue colored line, that vector is vector B. Here also I have drawn blue color, vector B is drawn here. And A and B are drawn, join 0 to Q. That will give the resultant of A plus B. So that is tail to tip method, and triangular vector addition also is similar, but you have to state in different manner. For example, if here we have two vectors, vector A and vector B. And the statement is like this: if we can represent these two vectors as the sides of the triangle taken in the same order, then the vector drawn in the reverse order to complete that triangle, that will give the resultant vector. I will state it again. It states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two sides of a triangle taken in one order, same order, the resultant is represented in magnitude and direction by the third side of the triangle taken in the reverse order, like an opposite order. Okay, I will explain again. Here we are having two vectors, vector A and vector B. And if these two vectors acting on a particle can be represented as the sides of a triangle taken in the same order. Now in this case it is possible. Vector A is drawn as one side of the triangle. Vector B is drawn as the second side of the triangle in the same order it is given. And O to P, then that means tail to tip method itself. That is the same order at the tip of vector A, tail of vector B is kept. So they are in same order. Arrow mark you see, O to P, then P to Q. Arrow mark is in the same order. And the resultant, how will you find? Resultant is the third side of the triangle taken in the reverse order or opposite order. Which is the third side of the triangle? You have to just join. O to Q you have to join. Third side of the triangle, that is the third side of the triangle, and in the reverse order. These and ഇവിടെ നിന്ന് ഇങ്ങോട്ട് പോയി ഇങ്ങോട്ട് പോയി. ബട്ട് സെയിം ഓർഡർ എന്ന് പറഞ്ഞാൽ ഇങ്ങോട്ട് വരണം. സെയിം ഓർഡറിൽ പോകാന്ന് പറഞ്ഞാൽ ക്യൂയിൽ നിന്ന് നേരെ ഇങ്ങോട്ടാണ് വരേണ്ടത്. പക്ഷേ ഇത് റിവേഴ്സ് ഓർഡറിൽ പോകണം എന്നാണ് പറയുന്നത്. ഫ്രം O to Q you have to move reverse order. So arrow mark should be like this. Reverse order. That is very important.